Am I recording? Oh yeah, sorry, I was making sure I was recording. Okay, so this is going over the steps to plug in the linear regression in Desmos. So we're looking for the line of best fit. So what we're gonna do for this, whenever we have a table, this is our X value, our X values, and these are our Y values. So in our Desmos calculator, we're gonna hit the plus sign, table. And now I just type in my values. So it's gonna take me a second, 4.9, 5.7, 5.8, 6.1, 6.3. Okay, and then my Y, 96.6. I'm about to get rid of my face right here. Okay, 168 and 178. Okay, so now that I have my table, all right, so then you go to another line, and that's when we're going to put in that equation that we were using in the last mastery. It's the Y1 squiggly mx1 plus b. Okay, so now I'm going to scroll down. Remember, our m is our slope and our b is our y-intercept. So, and here we're going to have to round. So m, it says 45.727. So whenever we're going to round to the nearest hundredth, which means 2 spots after the decimal. So 45.727. So this can just be rounded to 45.73 because this number is going to make this 2 round up. Okay, so that's our slope. And then our B is going to be negative 112 point, we can just leave it as 0.78 because that 2 will not make that round up. Okay, so I'm going to go down here. Okay, so Y equals 45.73, X minus 112.78. All right, so that is for that one. Okay, so now I'm going to go number 2. Okay, so same thing here. You're looking for line of best fit. So I'm actually going to skip this one because you're going to do it the same way. You insert, you hit plus sign, table, put your X and Y values, and then you do Y1, squiggly, MX1 plus B. Identify your slope and your y-intercept, and then you just find your equation. So for 3, okay, so for 3, again, you're going to start it the same way, but this one, once you find your line of best fit, you have to then use your line of best fit to solve what the question is asking you. So first I have to put these into a table. So rank is going to be my X values and points are my Y values. So plus sign, table. So 1, 2, 3, 4, 10. Okay, so I have all of those in. And now remember our next step, new line, put this Y1, squiggly, MX1 plus B. Okay, so now we need to do our line of best fit. I'm going to write it right here. So it's going to be Y equals. Our slope is -3 point. So we're going to do negative 3.32 because if we look right here, 0.315, this 5 will make that 1 round up. So negative 3.32x. And then our B is plus 105.33. Also, here's the thing too, with these rounding up, a lot of times, even if you don't round perfectly, you're gonna get a close enough answer. It's just sometimes you might have to get pretty specific depending on what your multiple choice. Like let's say down at the bottom, I had 39, 40, 41 as option choices, then the rounding would matter. But for this one, it wouldn't matter too much. So if you are confused about rounding, then don't worry about it right now. Okay, so now let me get rid of this. I need to write this again. So X and Y. All right, so it's asking us, it says, using the line of best fit, predict how many points the 20th ranked team received. So rank, again, is our X value. So I'm going to put, so we have our X, and we want our points, so that's our Y. So using our equation, all we have to do is plug in what we have. So we plug in 20 for X. And again, I can just use my calculator. I'm just going to do negative 3.32. Whenever you substitute in, make sure you use parentheses 20. And then plus 105.33. Okay, so here we have 38.93, 39 points. All right. And so this is a prediction, line of best fit. It's usually used for like statistics and predictions and things like that. So that's what these are used for. Yep, so that's that one. 4. Okay, what equation below? Okay, so this one's a little different. So this one, we are actually going to go, sorry, I'm like, I have my light turned off and I'm over around the other side of the computer. This one, you actually don't plug into Desmos. So actually, you know what? I can plug it into Desmos. There's a couple ways we can look at this, but I'm just going to show you. So in Desmos, remember, if you have a letter here, we can just type it in as Y in Desmos. So I'm going to type in a few different things. First of all, if I can already eliminate some work for myself because I know this is a negative slope. It goes down. So I don't even have to type these in. And actually, I don't even have to type, I already know the answer here because if you look, this is your y-intercept. It's going to cross at around, it's like at around 550, but it's positive. So it has to be this one. It can't be, the y-intercept cannot be negative 550. But if I do want to check to see if it matches, I'm just going to type in, okay, negative 5x plus 550. So y equals negative 5x plus 550. Whoops. I'm probably going to zoom way out. See, this is the thing. Ooh, okay, I'm going to, oh my goodness. All right, this is taking, okay, if I were to zoom out, you have to zoom up. Oh, I'm zooming out my whole screen. Okay, so forget that. Oh, goodness. Okay. All right, if I were to zoom way out, it would be the right answer. Okay, so that's that one. But you don't really have to plug anything into Desmos for this. If you wanted to, you could plug in the things and see which one matches. All right, this one. All right, one season it was found that Joe Smith hit home runs. Okay, so looking at this equation, even though it's different letters, it's still set up the same. So remember, it's like y equals mx plus b is our equation for slope-intercept form. So for this, our h is technically our y, and our g is technically our x. So g is our x values, and h are our y values. Which doesn't even really matter for this. I'm so sorry, ignore me. Oh my gosh, I'm so terrible. Okay, predict how many home runs Joe would have to hit if he had played 130 games. All right, so all you have to do for this one is you just read what it's asking you. It says, predict how many home runs Joe would have hit if the team had played 130 games. So we don't know H, but we do know games. So all you got to do is plug in 130 where G is. And you can do it in the calculator. I'm just writing it here. Plus 10. Okay. Scroll up. All right, so I'm just going to do, remember, use parentheses when you substitute, and then plus 10. Okay, so 42.5. You can't really play 42.5 games, so I'm going to round up to 43. So that's how you do that one. So even if you don't have y and x, even though I told you wrong before, you just look, you have to make sure you just match your variables. So this one's pretty nice because G represents games. All right, so 6. Which of the following graphs represents the line of best fit? Okay, so for these problems, you do need to use Desmos. You're gonna, even though it looks differently, it's still the same as a table. You're gonna hit plus table. You're gonna put all of your x values. So 1, 2, 3, 4, 5, 6. And then our y values, 12, 8, 6, 10, 5. Okay. And then I also can, if I do this, we put our formula we've been using. Okay, so this one I don't have to zoom out as much as the one before, if I can, oops. Okay, so if we look, a good way to tell where it crosses, okay, it crosses at 0, a little over 11 on the y axis. So this one, it crosses at like 7, so that can't be it. This one is positive, it can't be that one. It has to be this one. And look, it crosses right below 12. It's a negative line. And then if we look, if I do zoom, go over here, it crosses the x-axis at 12.72. Looks like it crosses, well, actually. Well, this is the closest one, but even though this says it crosses at like 15, I don't know what they're talking about. But that's the answer. So you're really just seeing which one matches the closest. Oops. Okay, so this is the same as the first two. You're just plugging it in, add button, table, enter your X value. So that's your femur length. So your left values of the table is going to be your X. The right values of the table is going to be your Y. Then you find your line of best fit. And then 8. Okay, so actually for 7, I'm just going to end up doing it because you're going to use your line of best fit for, you have to get 7 right in order to do number 8. So, and then this is the last one for this. I know this video is a little long. I'm sorry. Okay. 48 point. Oh. 2, 7, 5, 7. Okay, so Okay, so now again, y1 squiggly, mx1 plus b. We're going to scroll down to slope. All right, so it's going to be line of best fit is going to be y equals 1.97 because we can't round the 7 up. So 1.97x plus 78.42. So that is going to be our line of best fit. So I'm actually going to write it here so I have it for the next screen. Plus 78 point, oh my gosh. Oh my goodness. All right, well, I know what I wrote, 78.42. Okay. So number 8. All right, use the equation for the line of best fit to predict how tall a person is with a femur length of 58. So femur length is our X value. So again, we have our X value. So all we need to do is plug in 58 where our X is in the equation in order to find our height, which is Y. So 1.97 parentheses 58 plus 78.42. So our answer is going to be 192.68. There we go. Okay, so this is actually what I mentioned earlier, where sometimes the rounding matters and sometimes it doesn't. So this is an example of why it's important to have the decimals after your number. So like if I had put 2 instead of 1.97 or like 79 or 78, these two are so close together that it may have had caused me to get it wrong. But so this is an example of why you should try to round correctly, but not always. All right, that's it. Oh wait, oh my gosh, I should hit stop. Oh, I'm still not, no, yes.